You're on the ride with the progress. The Hillsong Express. Oh, yeah.
Hello and welcome to the Deep Sea Podcast, Pressurised, a short, punchy version of our main feed that gets right to the scientific point. If you like what you hear and you'd like to hear the full episode, you can find it in the same feed. And now, to get right to the point.
So the general sort of air-breathing, diving critters that do enter the deep sea, the record holders are things like the emperor penguins at 500 meters, leatherback sea turtles at 1,200 meters, sperm whales at 2,250 meters, and the record holders, the beaked whales, at almost 3,000 meters. And that must be an incredibly stressful thing to put your body through. And so that is going to be the topic of this episode. So we are going to speak to someone about the beaked whales. Visitors to the deep sea, but we'll allow it because they're cool. I'm joined by Dr. Nicola, lecturer in marine conservation at the University of Plymouth and an adjunct assistant professor of marine science and conservation at Duke University. Her research focuses on the ecology and behavior of marine mammals, particularly on how marine mammals use acoustic signals and how anthropogenic noise, so noise from people, affect their behavior. Thanks for coming on to have a chat with us.
You're welcome. Thank you for having me along.
We are a deep sea show, but it turns out there are some air-breathing marine mammals that go into the deep sea. Which are the sort of big deep diving species?
So there are a few of our cetacean species that like to head down to the deepest parts of the ocean. Probably the one that people know the best is the sperm whale. That's one of the larger whales that often features on whale watching trips in certain places. New Zealand, obviously, being one of the common places you can go and see those guys. Another one is pilot whales. They're pretty deep divers as well, although in comparison to the next group I'm going to mention, the pilot whales are probably pretty moderate deep divers. And then you have the beaked whales, or the family Ziphidae, or the Ziphids, we call them, that are what we term our sort of extreme deep divers out of the groups of cetaceans.
And for a lot of folk, nothing is going to pop into their brain when they hear the term beaked whale. I think a picture pops up when they hear whale, and then I say beaked, and a beak doesn't really fit on the classic shape of a whale's head. So if somebody was looking at a beaked whale, what would they be looking at?
Well, interestingly, they're actually quite a large family of cetaceans. So cetaceans is the word we use for whales and dolphins. And they're actually the second largest family after the dolphin. So that common image that people have of what a small dolphin looks like, your bull-nosed dolphin that you see on the TV or in Dolphinarium. And there's actually 22 species of the beaked whales in the family Ziphidae. And getting that normal search image is quite hard because actually they're quite different in some of their body shapes. Obviously, they're that nice streamlined shape that we associate with a whale, but they can range in size from 4 meters up to sort of 13 meters, depending on the species that you're looking at. And often they sort of have quite sort of bulbous torpedo-shaped bodies almost, with a small beak at the front that you might associate with something like some of the smaller dolphins. And then going into a shape at the back, their tails tend not to have a notch like we associate with other whales and dolphins. And then the really different thing about them is unlike something like a big humpback whale that people might have seen on the TV that have those big white pectoral fins, beaked whales have very small pectoral fins, so those fins on the sides of their bodies. So they look quite these sort of stubby little fins, and that's just to make them as streamlined as possible to help them as they're diving deep down into the ocean.
Oh, that's amazing. So one of the most specious groups, one of the most diverse families of whales and dolphins. It's not one that pops up in our minds, and that we'll dip into why they're so infrequently seen. What are they doing out there? How are they living their lives?
Well, you're right. They are. They're actually one of the least known groups of mammals out of any groups of mammals. So that's why people don't have that search image. And the thing that probably makes them even less known to humans is where they're actually living. So these guys live in deep water areas, and that can be around off deep drop-off zones, or also they can be island associated if you have some areas where there's some steep drop-offs around islands. So those ones might be seen by people a little bit more frequently, but typically they're in these deep offshore waters that are not really that accessible for your average human to get to, unless you've got a well-equipped boat to actually get out there and see them. And the really interesting thing with these guys is, even though we say there's about 22 species, some of these have only really been described in the last couple of decades, and there's still a few of those species that we maybe only know from a skull that has been found washed up on a beach. And really, out of all of those species, there's only 3 or 4 that are reasonably well described. And that's due to how far offshore they live, in the areas that are harder for us to get to. And also, they're not one of these species that spends a lot of time jumping about at the surface like you might associate with something like a humpback whale.
They don't show off.
No, they don't tend to. It's not saying that they don't breach. If they want to, they can. But yeah, they're not one of these look at me species like a humpback whale or a dusky dolphin.
And living out there so remotely, we're probably getting less strandings. We're not finding skulls and vertebrae washing up. They're sort of hidden yet abundant.
Yeah, it's really interesting. Yeah, generally, because they live so far offshore, I think for a stranding, it's got much further distance to travel for it to wash up on a beach for someone to find. And they may well just sink out there in the deep sea. You do get strandings of them. Some of the populations that live maybe nearer to some of the island chains in the Caribbean or in other sort of island areas, that's where they probably get a lot of them washing up. And obviously when they start decomposing in the sea, and just that time it would take for them to actually wash up and get to the beach.
Yeah, once they're floaty and smelly.
Yeah.
That wonderful stage.
Yeah.
What's a day in the life of a beaked whale? How are they spending their time if they're being all cryptic and avoiding us?
Yeah, I guess I'm generalizing about beaked whales in general. The one I study is the goose-beaked whale, Xiphias cavarostris. So that's the one that I know the most about, but there are a couple of other species. But for those Xiphias, they tend to spend the majority of their time under the water. So these guys have this pattern of diving where they dive deep on, and if we say, again, it's all sort of averages, average an hour to do a foraging dive. So a deep dive for them is crazy deep. I think it's like thousands of meters down.
Wow.
They can dive and they forage. The only reason we're assuming they're foraging down there is because they create these echolocation clicks that other people have associated in other species to be searching for food, and these sort of regular clicks you get followed by these buzzes, which we assume is them capturing prey. So they dive deep, these foraging dives, and then they come up to the surface for about, on average, 2 minutes where they're breathing, actively breathing. And then they do this series of, some people call them bounce dives. Some people call them shallow dives, which is slightly misleading because they then do these series of dives that are in theory shallow, but are still to 300-400 meters.
Oh, that's weird.
I know, it's really weird.
It's almost like a deco stop. They sort of stretch their body to its limit and then come back up shallower.
Well, yeah, that's sort of the theory, in that they do these big deep dives and then they're doing these shallower dives, which we call an inter-deep dive interval. So just that time, they're still diving, but it's the time between those big deep dives before they head out again. So you get what is sort of these patterns of one really deep dive and then maybe 4 or 5 shallower dives with 2 minutes at the surface between, and then they're back to a deep dive.
That's incredible.
Yeah.
So little rest after pushing, no free diver is going to turn around and go straight back in after 2 minutes of huffing on the surface.
Yeah, it's really interesting. And I've looked quite a lot at that diving behavior, and we can get into that, I guess, with how they're doing that. But yeah, it's a really interesting approach to be diving that deep, breathe for a couple of minutes, and then for any other animal it would be going deep again, but for them it's shallow.
And they seem to, on the deep dives, they seem to be heading for the seabed, and then I'm guessing on the shallower ones, of course, they're going to be in the more open ocean. So what are they doing when they're down there? Do we think have we got content analysis? Do we know from any of the strandings what they're eating?
Yeah, it's a good question. So back to the first bit about are they dive into the seafloor. We think that's what they're doing, and we've just been trying to explore that a little bit with some of our acoustic tags that we put on the whales to see if we can get really cool bottom echoes, like echoes from their echolocation clicks that are coming back off the bottom.
You're listening in on their sonar.
Yeah, listen in to see what they're doing, how they're using that environment. So yeah, generally we think they tend to forage within a few hundred meters of the seafloor, but other populations, that isn't necessarily what they're doing all the time. So yeah, we think they're sort of bathypelagic foraging down, maybe using the drop-offs and the seafloor and the features down there, and then diving down to more sort of just open ocean, doing whatever they're doing on those shallow dives.
Oh, and there's some thoughts of, me and Alan were on a paper a few years back, finding these weird traces on the seabed, these weird sort of, it looks almost like stitching, like a little trough at regular intervals. And is the thought that they're actually sifting through the seabed? They're actually pushing that snout into the sediment and looking for things buried, or do we not really know what they're doing down there?
Yeah, well, there is some sort of that, definitely. Yeah, these beaked whale troughs that people think are associated with, the whales going right down to the seafloor. So yes, they could be doing that. They have these really interesting dentition, if you like, in that they don't have sort of functional teeth. The males have these tusks at the front, so they're not like chewing food as you would think of what humans do. But we think they're sort of sucking up prey as they're heading down to the bottom. So yeah, maybe they're sucking things off the floor. Maybe they're foraging mid-water. We do have some buzzes from our tags where they're not potentially not right at the seafloor. So yeah, I think we're not really sure, to be honest, exactly what they're doing down there in terms of exactly what prey they're targeting and exactly how they're capturing everything that they're chasing.
So not much found in the stomachs of ones that have been washed up. The difficulty always is that a dead whale that washes up is not a healthy whale. So it's kind of the opposite of a survivorship bias. You don't see what a healthy whale is eating. You just see what killed one.
Yeah. So there has been some stomach contents analysis for this species that sort of suggested it's this sort of squid and deep water fish that they're potentially eating, maybe some little squid beaks in there. But the thing with these guys is because they spend so much time under the water, we don't know when they're digesting their food, because all of their time, once they go below sort of 100 meters depth, in theory, they're collapsing lungs and shutting things off with their adaptations of their diving physiology. So we don't know when they're digesting things, and maybe they're eating very small things that digest very quickly. So there often isn't a huge amount of stomach contents there. Or maybe when they strand, as you say, they're not as healthy whales, maybe they expel that stomach contents, but there isn't a huge amount of information. And often as well, by the time they're on the beach, they're in a pretty nasty condition. So I think probably a lot of the best information on stomach contents is from whaling records, actually, when they were catching healthy whales.
Oh, wow.
And if there's any stomach contents information there. But generally the thought is sort of squid and deep water fish. But I was sort of hoping you could tell me what deep water
what
fish
they're
they were
running into.
eating at those depths.
Well, it's got to be worthwhile. Like, it's a huge effort. It must take so many calories to do this. So it's got to be profitable. They've got to be consuming more calories when they're down there.
Yeah.
I think, what's the average deep dive, and what's the kind of record we currently have for them?
So on average, they're diving for about an hour at a time, but they're not foraging for that whole time. And these guys have quite a different, we're sort of looking into those different foraging strategies in terms of they don't tend to actively echolocate for a lot of the dive, which things like sperm whales and pilot whales do. People find sperm whales in the wild by using a hydrophone because you can hear their clicks, and then you can track them underwater, because generally when a sperm whale's under the water, it's clicking all the time. Whereas beaked whales tend to dive and then just start clicking when they're foraging. They do click for a reasonable amount of that dive, but there seems to be a very definite period when they're clicking and actively foraging, and the rest of the time they're very quiet. At least they're not making what we would think were foraging clicks. So it's about an hour that they're diving, but I say the proportion of time they're foraging is probably less than half of that. They have been recorded down to almost 3,000 meters, which is insane.
Yeah.
But the whales that we look at is mostly like 1,500 meters is probably the average. We have recorded some long duration dives, like crazy long duration dives, like well over a few hours, which seems insanely long for them to be under the water.
Holding your breath for multiple hours and
depth.
diving to over 3,000 meters deep is nuts.
And actively foraging as well, right? That's the thing.
Yeah, not just having a rest down there.
Yeah, it's not that they're hibernating or something. They're actively doing something whilst they're there.
So you can't do something like this lightly. There must be loads of adaptations that they have to deep diving. And you mentioned their lungs collapsing. What are some of the sort of super deep sea adaptations to air breathers, which just feels so weird?
Yeah, it's interesting, isn't it? Because for these deep divers, you have a division of resources, if you like, that most animals or mammals don't have to deal with. So you've got sort of air at the surface and food at depth. And you have to go through a different physiological state to access two of your main really important resources, which is not something that generally happens in mammals. So it's quite interesting. So all divers, when they're foraging at depth, obviously they can't breathe, the air breathers, obviously. So they need some way to have improved oxygen storage in their tissues, in their blood, to be able to provide their organs with oxygen while they're diving. Because remember, they're actively moving as well. So there's metabolism going on there. They obviously deploy this dive response, which we do see in human free divers as well, where you get a slowing of the heart rate, this bradycardia, where your heart rate slows, and sort of a redistribution of blood flow. So the body would distribute blood, and this is what we think happens with the whales. Obviously, they distribute blood to those more important organs, like your brain and your heart, as opposed to sending blood to the peripheries of your limbs and your skin. So they have that, and they have a lot of I'm not a physiologist, but they have a lot of sort of physiological adaptations with the types of muscles they have, the amounts of myoglobin, which obviously is very good at storing oxygen in the tissues, and even how much they invest in things like brain tissue. So they actually have quite small brains. Oh. So they invest less in these sort of tissues that are metabolically expensive, if you like. So there's a huge range of adaptations that these guys have.
I was reading as well that the lungs collapsing, as horrible as it sounds, is actually a good thing, because diving that deep, they would have all sorts of gas issues. And I think there was shallow water blackouts as well. So it was almost by the lungs collapsing and they're no longer performing gas exchange, it kept them safe from, say, getting narked at depth. And then on the way back up, just as they were sort of approaching shallow water blackout, that's when the lungs would reinflate, not with any fresh air, but just with the same air that was in there, but compressed almost away. We'd give a little oxygen boost just at that last hurdle, which is just amazing. This seems like such a push of what they're capable of.
Yeah, they are really fascinating, actually, because obviously most animals have got super adaptations to the niches they exploit. But yeah, the hydrostatic pressure that you're dealing with is a real challenge of diving, because so your airfield structures obviously get compressed, and that would potentially put nitrogen would enter your bloodstream. So that's where your risk of the bends comes. So by collapsing those airfield structures, then you're regulating the chances of that happening, if you like. And there's also evidence from a lot of divers, I don't know, we've got it from beaked whales, but I believe some of the seals, that often they almost like breathe out before they dive, in a way, to get rid of that excess air, because they're going to collapse those airfield structures. So yeah, it's like these two challenges of metabolizing without respiration. So their tissues are constantly using oxygen at depth, but obviously they can't renew their oxygen stores. And then that hydrostatic pressure, where airfield structures are going to be compressed and could potentially, as you come back up, as you say, there's that risk of the bends as nitrogen would enter the bloodstream in the bubbles and cause the bends. So they're clearly super adapted to be able to deal with those challenges.
So to flip to your work, you've mentioned a few interesting things. You've mentioned acoustic tagging. You've mentioned recognizing individuals. What is your research like? How are you studying something that seems to be, so well hidden?
Yeah, I sort of flip between really liking beaked whales and really hating beaked whales, because they're really, really challenging to work with, but it's super rewarding, I guess, when you can work with them. With any marine mammals, I think a lot of the well-studied groups and populations are in places where they're accessible. And we're very lucky in the study site that I work with. And I have to mention here, before I was at Plymouth, I was over at Duke University in the US, working with a great group of people out there that sort of developed this study on beaked whales. So Andy Reid's group and Doug Nowacek's group. And they basically were out off Cape Hatteras, which is on the east coast of the US. So there's a drop off quite close to shore. It's still about sort of 40 miles, but it's close in terms of other places.
Fuel cost isn't so bad.
Yeah. So you can get out and back in a day, but you have to sort of go to see a chiropractor afterwards. But yeah, it is sort of an accessible place for beaked whales. But when they were out there doing some other studies, they took some great observations that, they look like beaked whales, and then we're seeing them again. And then there was another group that were running some aerial surveys that spotted these beaked whale groups out there. And then a student put out some acoustic recorders, and we're starting getting detections of beaked whales. So we're building up an area of where there's sort of a hot spot of these beaked whales. And now we sort of know a rough area where they're more likely to be. So it's challenging when you're out there, and really you can only see them in very low sea states. So sea states 0 and 1, which is basically when there's no white water on the surface, because they're very, very cryptic. As I say, they just sort of come up, they breathe and they go again. So it's a lot of time looking at the surface of the water, and it's a lot of time just seeing nothing. And then when we do see animals, you've got, a very short window of a few minutes to actually get over and look at these guys. We spend a lot of time taking photos of them, because with all marine mammals, generally, there's some part of their body that has natural marks, and whether that's their dorsal fin, that's usually the easiest thing because it sticks out above the surface of the water. So you can take photos of those dorsal fins and you can match individuals, because once they get those marks on their fins, they don't tend to change unless they get more marks over the top. But if you get enough regular photos, you can match individuals over time. So that's how we know that we're seeing the same individuals. With the Cuvier's beaked whales, they have these really different body colorations. As the males get older, they get more white, which is really interesting. Not quite sure we know exactly why that is, but that does actually, a white whale is much easier to see than a brown whale. So it's really just looking and putting yourself in the right position and spending a lot of time out there looking. And obviously we have many days where we see nothing, but we have many great days as well where we do see them.
And you're actually getting tags onto them. How are you managing to approach and get something onto the body?
Yeah, so there's the tags that we use, these sort of D tags, these archival tags, and D tags were developed by a group of very clever people at Woods Hole, led by Mark Johnson and Peter Tyaker a number of years ago. And they're very specialist archival tags that record accelerometry information and then acoustics. And we're able to just put them onto the whales with a very big, long carbon fiber pole that just sort of sucks on the back of the whale. So it's not an invasive tag. And then after, we have to think about how long we're going to put them on for, because where we work, if the tag pops off, then it could be off on the Gulf Stream across the ocean, because you have to be able to go and pick it back out of the water. So it's very much, you need people that have got strong arm muscles, I'd say, but very specialist skills. So we've got some great boat drivers that have got lots of experience driving around whales. You have to approach very carefully. You have to often take many hours watching the whales till you know exactly who you're going to try and tag. So, and it's all done obviously under permitting from the Marine Fisheries Service and NOAA, and under the Marine Mammal Protection Act in the US. So it's a very strict permitted activity, and only a few people can actually do it. So we're very lucky that we have the skills in our field team to be able to do that.
Saying that we really struggle, and this might be sort of out of your area of expertise, but you mentioned that we have the same dive response or a similar dive response. Why have we still got that? Is this something that's within most mammals?
Yeah, it's a good question. And I say I'm not a physiologist or a human evolutionary biologist, I guess. But yeah, I think just for any air breathing mammal, there is that inbuilt response, perhaps from the original evolution of mammals from the ocean, that you have this sort of inbuilt response of you don't actively breathe underwater, and your body goes into a preservation mode because it's not your normal habitat by conserving energy and taking those measures, I guess, of potentially slowing heart rate. Although I think probably for your average human, when you're thrown into cold water, I'm not sure that dive response kicks in as well as it does.
It can be overridden.
Yeah, it can be overridden.
Is there anything that is often misreported that you'd like to set the record straight on?
Probably that people generally just think sperm whales are the deepest diving whales, and the beaked whales definitely go deeper than them. So that's probably, but it's just because sperm whales are more well known and people are much more likely to have seen them or heard about them.
And everyone does that classic giant squid fighting a sperm whale.
Yes.
The battle we never see kind of thing. So these quiet, subtle whales snuffling up probably little fish and squid. But it seems like they want to be forgotten. They want to be sort of overlooked so they can hide away.
I think they're quite happy just getting on with their everyday lives. Generally, they are reported to strand with military sonar. But yeah, that's sort of how they were getting more visible to people, was this link between human activities and beaked whales, which is where a lot of my research works, looking at how their diving changes with the effects of noise.
Is the link pretty strong? It does seem to be our activities that are disrupting them.
Well, it's complicated. There's a couple of published papers actually about it where they do seem to react in terms of some sort of behavioural response, but we don't really know the mechanism, and that's sort of what we're looking for now. So I don't think it's unsurprising though that if there's a loud noise somewhere, then things respond to it. I mean, I think that's pretty commonly known of mammals.
Shouldn't be controversial,
yeah, it
really.
shouldn't be that controversial, but there's certainly suggestion that some mass strandings in beaked whales are associated with military activities in different parts of the world. So there's published information on that. So a lot of our work is starting to look at why that might be, because obviously it's not all the time. So you're just trying to tease out what might be the mechanism that would cause animals to react in a different way. And that's challenging to study because there's so many different aspects of social behavior and age classes of the animals and where they're distributed, all of those things that we don't really know a huge amount about for beaked whales.
The data points are so sparse.
Yes.
Even with the data we have, it's like, well, is this lining up? Is this?
Yeah, and it's interesting. The other thing, I guess, for these guys, when you think of the deep divers, sperm whales utilize very similar niches in terms of breathing at the surface and foraging at depth, but you've sort of got one species that's colonized the world in a very successful populations in many oceans, whereas beaked whales seem to have the same sort of strategy of diving deep to forage, but they're split into a lot of different species that seem to be more, even though there's quite a few populations around.
They're obviously not roaming and mixing.
Yeah, we don't really know how far they go, but it's interesting, I guess, for the evolution of species. Like the strategy in sperm whales just resulted in one species, where for beaked whales, we've got like 22 different species that are sort of not isolated as such, but more restricted in their distribution in different areas. So yeah, things like that are really interesting, and we don't really know too much about what's driving that.
Just thinking, actually, I had a past life as a marine mammal observer.
Okay.
And one of our best tools, especially for cryptic species, was PAMS, was passive acoustic monitoring.
Yes.
And I would have to do a search for marine mammals in the area before they could start acoustic acquisition, so that before they start firing these air guns that bounce sound waves off the bottom. And we'd miss these.
Yes.
They're quiet at the surface. They're really, really subtle. And yeah, it would be really hard to mitigate against disturbing them other than knowing that they're in the area.
Yeah, definitely. And they do, one of the things that has come up from sort of the responses to sound is they do potentially stop clicking as well. So that was one of the big sort of, is that really impacting them? If there's lots of noise and you interrupt their foraging behavior, then that could obviously have knock-on effects. But yeah, in that instance, there's something going on, so they're just even more quiet than they would normally be.
Their instinct is very much to hide,
yes,
and it makes it difficult.
Yeah. They are fascinating animals, but yeah, we do come across a lot. It's like, what are they doing that? Why are they doing that? I don't know. It doesn't make sense.
It looks like such hard work.
It does. It does. And if you sort of plot them with body size and oxygen storages, across your average curve or line across mammals, they don't sort of fit in very well. So they're clearly adapted in ways that we don't really fully understand. Are they
the aquatic bumblebee? Are they when you do the physics, this shouldn't work?
Yeah, it's the hummingbird or something, or something like that. Yeah, almost.
They're obviously doing something we haven't fully understood because this doesn't look profitable.
Yes, yeah. It's like, how is this really a good strategy? But clearly it is, because there are at least 22 species, and they are in populations all over the place, so they're clearly doing well. But I guess the main concern with noise is that maybe there's a bigger impact on some of those populations, but we really don't know that much yet. But we're getting there.
There's so much we don't know.
For such a large group of mammals, right?
Yeah.
Well, it's one of the least known groups of mammals, and there's all these just fundamental basic questions. Even for our work now, we know, we can infer when they're foraging from the clicks, but in terms of other behavioral state, we don't really know. Like when do they sleep? When do they digest food? When do they reproduce? When do they socially interact? When do they do all these things that other mammals do?
Yeah. How do you coordinate? How do you find your pod again?
Yes.
The more, like, it's an immediate wow. And then the more I think about actually how an organism lives like this, it's just like, how about that? How about that? How about that? Like, it's a really difficult way of living.
It's fascinating. And we had one of the guys I work closely with, Will Trophy. He's done some great manuscripts on looking at sort of social cohesion and whales. He's some nice parts of whales potentially diving together. So we do believe there's some social aspect to it. But again, how do you conduct those social relationship at 2,000 meters when everything in your body's turned off? And then how do you find each other again in this vast ocean? Some really nice, interesting questions. And probably we are sort of limited by the technology we have to record data on them more than anything else.
There's still so much to learn. So this is a really, really fertile ground. But I understand your frustration as well with wanting to know.
Yes.
But thanks for coming on and sharing what we do know. I have a newfound appreciation for them. Thanks so much for having a chat with us, Nicola.
No problem. Thank you.
was a pressurized version of one of our longer episodes. If you enjoyed that and you would like to hear the full length episode, just match the episode numbers and you'll be able to find the full length version in the feed. Thanks for listening. We'll deep see you next time, and I abyss you already.
Ride with the progress, the hills unexpressed.